Now, number 36. Your weight depends on where you are. This one should be pretty obvious because, like for example, your weight by definition is the force exerted by you upon you in a gravitational field, and so it would depend on the strength of the gravitational field, and or you weigh a certain amount on Earth. In space, you're weightless. So you want to lose weight, go to the moon. The gravitational attraction of the moon is less than it is on the Earth. Or even more significantly, you weigh less at the equator than you do at the pole. Because as the Earth rotates, it's not perfectly spherical. It's going to be more of an ellipse, and it bows out at the equator. And so the distance of you from the center of mass is different. And so the gravitational force is different. So you weigh less at the equator than you do at the North Pole. Probably not a measurable thing that you would measure on a bathroom scale, but there is a difference. You definitely can lose weight by going into space where you're weightless. So we could have our own weight loss program. And now, that is a true statement. Now, number 37, nonmetals form non-conductive brittle solids. This is a defining characteristic of metals and nonmetals. Non-metals, when I say non-conductive, I'm usually discussing electricity, but I could also be discussing heat. So this is a defining characteristics of nonmetals. Look at things, think of the things to the right of the staircase. Those that are solid, which aren't very many of them, a lot of them are gases, some of them are liquids. But if you look at a piece of solid sulfur, for example, or a piece of solid phosphorus, as another example, these don't conduct. They're brittle, they're soft. They would break apart. They don't conduct electricity. The exception would be the carbon. Has many forms. Graphite being one of the softest materials, pure carbon, but due to its structure, it is very soft, but it conducts electricity. So it's the rare exception, and in contrast, one of the hardest materials is pure carbon in the diamond form, which does not conduct electricity and is not brittle. So it's not soft. So that would be the exception. Generally, as a rule, nonmetals form non-conductive brittle solids. So this is true. This is one of the defining characteristics. Part of the homology of how things, form, transform. Now, another homological aspect is number 38. Metals readily form compounds with nonmetals. This is, again, another defining characteristic. So this is true. Metals don't readily form compounds with other metals, which is something that needs to be taken into account. Now, nonmetals, on the other hand, readily form compounds with metals and each other. Metals readily form compounds with nonmetals, however, they don't readily form compounds with other metals. There are some cases where certain conditions exist where they will alloy with other metals, but they won't alloy with all metals. So this statement is true, but I could have given you any variant of this, and so be prepared. This is testing the homology again, the qualities and things that we need to know about things, that once you understand one metal, you understand all of them. And now, number 39, the chemical identity of a compound is changed in every chemical process. I'm using the word process in place of the word reaction. And what a reaction is a transformation. Hence, we talk a lot about homology, how things transform. And the chemical identity of a compound, this is pretty much the definition of what a chemical identity is. It can only be changed if there's a reaction. Okay, so this is pretty much the definition of a reaction. The chemical identity is changed and there's been a reaction. If the chemical identity is not changed, well, then there has been no reaction. There is no process, and it's not involved in the process. It could be a spectator, could be hanging around watching things happen, but it's, or, you know, anthropomorphizing, but it could just be there in the presence of a reaction, but it's not a participant. So, in any chemical reaction, the reaction is corresponds to the compounds that change their identity. There is a change, some sort of a change. So this one is true. Now 40. Solid metalloids are semiconductors of electricity. This is, again, a homological property, homology of metalloids. Metalloids are intermediate between the two extremes. It turns out that metals are conductors, nonmetals are insulators, generally, and metalloids are semiconductors. The distinction between a conductor and a semiconductor really lies in the resistance, the observed resistance as a function of temperature. Conductors, their conductivity decreases with increasing temperature. Semiconductors, observably, the conductivity increases with increasing temperature. So that is where the distinction lies. And so they're intermediate between the two extremes. Between a conductor and an insulator is a semiconductor. It is intermediate between the two extremes. So it's not an insulator, it's not a conductor, it is a semiconductor. It's a semiconductor of heat and electricity, if we want to be real technical. So this is true. And that completes that.